Welcome to the deep dive. Today we're taking a deep dive into artificial intelligence.
AI,
It's a
yeah.
field that's just exploded, hasn't it? From like sci-fi concepts to, well, something we bump into every single day.
It really is.
It's reshaping whole industries, changing how we work, and honestly raising some pretty big questions about where we're headed.
Absolutely. It's amazing how fast AI has become so central, moving from theory, in labs to actual practical uses everywhere.
So for this deep dive, what's our mission?
Well, we want to explore AI from all angles, look at the core ideas, some surprising innovations, the big challenges too, and really how it's fundamentally impacting our future.
And for you listening, think of this as your essential guide.
Mm.
We want to help you get a solid handle on AI quickly and thoroughly.
Yeah, cut through the noise a bit.
We're going to uncover some genuinely fascinating facts and hopefully give you that shortcut to being really well informed about this huge transformative force.
And to guide us, we're leaning heavily on Artificial Intelligence in Action, Real-World Applications and Innovations by Ahmed Banafa.
Great resource.
It really helps unpack the complexities.
Okay, so let's just jump right in then. What is artificial intelligence at its heart?
Well, at its most basic, AI is about building computer systems, right? Systems that can perform tasks that usually need human intelligence.
Like what kind of tasks?
Oh, things like learning from experience, solving problems, understanding language, recognizing patterns, even making decisions.
So machines that can kind of think or mimic thinking.
Essentially, yeah. Enabling machines to learn and operate in ways that mirror human cognition. They're trained to spot patterns, understand commands, process huge amounts of data.
Yeah, make decisions based on it.
Exactly, informed decisions. Now, it's a massive field, so naturally there are different ways we categorize AI.
Right, makes sense. So what's one way to break it down?
Well, one common way is these foundational categories, almost like levels of capability. You start with reactive machines. These are the simplest. They just react based on pre-programmed rules. No memory of the past.
Like Deep Blue playing chess, only seeing the current board.
Precisely. Then you have limited memory machines. These can use recent past data to inform immediate decisions.
Like the lane assist in my car. I need to know where the lines were a second ago.
Exactly that kind of thing. It learns from recent observations.
Okay, what's next?
Moving into more conceptual territory, there's theory of mind AI. This would be AI designed to understand human emotions, intentions, beliefs.
Wow, that sounds complex.
It is very much still in the research phase. And then the really big one, theoretically, is self-aware AI.
Cautiousness in machines.
An understanding of its own existence, yeah. Truly profound and, well, maybe quite far off, or maybe not, depending on who you ask.
Okay, so that's one way to classify them. What about practically, what we see day to day?
Right. Another very common classification focuses on the scope of the AI's intelligence. So first, you have narrow AI, or sometimes called weak AI. This is pretty much everything we have right now.
So like my phone's voice assistant or image recognition software.
Exactly. Designed for one specific task. It might be brilliant at that task, but it can't, suddenly decide to learn philosophy. It lacks general intelligence.
Got it. Narrow focus. What's next?
Then there's the goal, for many, of general AI or strong AI. This is still theoretical.
Human level intelligence.
Yeah, an AI system that could perform pretty much any intellectual task a human can. Flexible, adaptable intelligence across different areas.
Still science fiction for now.
Pretty much, yeah. And then pushing that even further, you get super AI.
Okay, now we're really in sci-fi territory.
Definitely. This is AI that would massively surpass human intelligence in basically every field. Creative, problem-solving, social skills, you name it.
That's where a lot of the more dramatic, maybe fearful narratives come from, isn't it?
Often, yes. The idea of intelligence far beyond our own comprehension or control.
Okay, so let's pivot from those broad types to the actual methods. How does this stuff actually work under the hood, the technical approaches?
Right. There are several key ways AI learns and operates. One of the older ones is rule-based AI. Expert systems, basically.
Like if-then statements.
Exactly. A predefined set of rules. If you see symptom X, consider condition Y. Good for specific, well-defined problems.
Okay, what else?
Then a huge one is supervised learning. This is where you train the AI on data that's already been labeled.
So you show it pictures labeled cat and pictures labeled dog.
Thousands of them, yeah. And it learns to tell the difference based on those labels you provided. Very common.
And the opposite would be?
Unsupervised learning. Here, the data isn't labeled. The AI has to find patterns and structures all on its own.
Like finding natural groups in customer data without being told what groups to look for. Clustering.
Exactly. Discovering hidden structures. Then you have reinforcement learning.
Ah, the trial and error one.
Yeah, learning through rewards and punishments, like training a pet almost. The AI tries actions, gets feedback, and learns strategies that maximize rewards.
This is how they learn to play complex games, right? Like Go or chess.
Precisely. Or how robots learn to walk or manipulate objects.
Then there's deep learning.
That uses those neural networks, the ones with many layers.
Exactly. Deep neural networks. They can find incredibly complex, subtle patterns in massive data sets, powers things like advanced image recognition, natural language translation.
Okay. And the one making all the headlines recently.
Ah, yes. Generative AI. This one's fascinating because it doesn't just analyze or classify, it creates.
Creates new stuff.
Totally new content, yeah. Images, text, music, code. It's trained on vast data sets of existing content, learns the underlying patterns and style, and then generates novel outputs that are similar.
The applications seem huge.
Well, they are. In computer graphics, generating stunningly realistic images or video. For game environments, special effects.
Product design. Sure. And in natural language processing, generating human-like text, writing articles, poems, code, answering questions in a conversational way.
What's the big advantage here?
Creativity and uniqueness, really. It can go beyond just applying fixed rules or finding existing patterns. It can synthesize something genuinely new.
But are there downsides? Concerns?
Definitely. Since it learns from existing data, it can, well, pick up biases present in that data.
And potentially amplify them.
That's a risk, yes, leading to unfair or even offensive outputs. And sometimes the generated content can just be nonsensical or factually incorrect. Quality control is a major ongoing challenge.
So when we talk about ChatGPT, where does that fit in?
ChatGPT is a prime example of generative AI, specifically for text. It's built on what's called the GPT architecture generative pre-trained transformer.
Pre-trained on what?
Massive amounts of text data from the internet, books, articles. That pre-training is what allows it to generate such fluent and coherent responses when you chat with it.
The potential seems massive for, like, customer service bots, writing assistants.
Huge potential for improved natural language processing, personalization, education. But again, challenges remain. Ethical concerns, those biases we mentioned, privacy issues with the training data.
Right. And for someone wanting to actually learn this stuff, get into generative AI development, sounds tough.
It is. It's a pretty formidable learning curve, not gonna lie.
Why is it so challenging?
Well, first, there's the math. You really need a solid grasp of things like linear algebra, probability, calculus. That's the foundation.
Okay, the math backbone.
Then the complexity of deep learning itself, understanding concepts like backpropagation, how the network actually learns optimization algorithms, figuring out hyperparameter tuning.
Hyper what now?
Hyperparameter tuning. It's like adjusting the knobs on the learning process itself to get the best results. It requires deep technical understanding.
And I guess you need serious computing power, too.
Oh, yeah. Training these huge models, it takes serious horsepower. We're talking expensive GPUs, TPUs, lots of processing time and energy.
Not something you can just do on a laptop easily.
Not for the cutting-edge stuff, no. Plus, the algorithms themselves, the architectures like JANs or VAEs, they're incredibly intricate.
And the field changes so fast.
Constantly. What's state-of-the-art today might be old news in 6 months. You have to be committed to continuous learning.
And you mentioned needing knowledge from different areas.
Absolutely. It's very interdisciplinary. You might need computer vision expertise for images, NLP for text, signal processing for audio. It brings a lot together.
It really sounds like a marathon, not a sprint.
Definitely a marathon.
Okay, let's shift gears a bit. What are the actual the programming languages people use to build this AI?
Right. The lingua franca, if you will. Well, Python is king, hands down.
Why Python?
It's relatively simple to learn, very readable, and crucially, it has this enormous ecosystem of libraries specifically for AI and data science.
Libraries like?
NumPy for numerical operations, Pandas for data manipulation, and especially scikit-learn for general machine learning tasks.
So you can use Python for, say, analyzing text sentiment.
Yep, using libraries like NLTK or Spacey for natural language processing, or for computer vision tasks, recognizing objects and images, you'd use something like OpenCV.
And that machine learning classification you mentioned, like spam detection.
Scikit-learn is perfect for that, building models to classify emails as spam or not spam. Even for reinforcement learning, Python, with tools like OpenAI Gym, is very common for training AI agents in simulated environments.
Is it only Python, though?
Not exclusively, Java is still very important, especially for large-scale, enterprise-level AI systems where performance and scalability are absolutely critical. Think big data platforms.
Okay. Any others?
R is widely used, particularly in statistical computing and academic research. It has great packages for statistical modeling and visualization, like OpenPart for decision trees.
And I heard something about AI in web browsers using JavaScript.
Yeah, that's becoming a thing. Frameworks like TensorFlow.js allow you to run machine learning models directly in the browser.
Wow. So interactive AI experiences right on a web page.
Exactly. It opens up a lot of possibilities for client-side AI.
Okay, so you've picked your language, you have your tools. How do you actually create an AI model? What's the process like from start to finish?
It's generally a pretty defined five-step journey, though it can be iterative, of course. Data. It all starts with data. So step one, data collection and preprocessing. You gather the raw data you need, then you have to clean it, handle missing values, fix errors.
Make it usable.
Exactly. Transform it into the right format. And then crucially, split it into sets for training the model, validating it during development, and testing it at the end.
Okay, data sorted. Step two.
Step two, model selection and architecture design. This is where you choose the right type of AI model for your problem.
Like choosing between a CNN for images or an RNN for text.
Precisely, or maybe a GAN if you're generating content. And then you design the specific structure of that model, how many layers, how they're connected, that kind of thing.
Makes sense. Step three.
Step three, model training. This is the core learning phase. You feed the training data to your chosen model architecture.
And how does it learn?
You define a loss function that measures how wrong the model's predictions are. And an optimization algorithm, that's the method the model uses to adjust its internal parameters, its weights, to minimize that loss. It goes through the data many times, gradually getting better.
Okay, training done. Step four.
Step four, model evaluation and tuning. Now you test the trained model on data it's never seen before, that test set.
To see how well it actually performs.
Exactly. Using specific metrics like accuracy, precision, recall, whatever is relevant. If it's not good enough, you go back and tune those hyperparameters we mentioned earlier.
Tweaking the learning process itself.
Right. Maybe adjust the learning rate or the complexity of the model. You might compare several different models to see which one performs best. It's an iterative refinement process.
And finally, step five.
Step five, model deployment and integration. Once you're happy with the model's performance, you need to get it out into the real world. That involves saving the trained model serialization, maybe exposing it through an API so other applications can use it, integrating it into your product or system, and then very importantly, monitoring its performance over time and updating it as needed.
And underlying all of this is more math.
Always more math. Linear algebra, probability theory, calculus, optimization techniques, they're the bedrock supporting every step.
Okay. Now, you mentioned something earlier about large language models, LLMs like ChatGPT, and a surprising way to think about them.
Thinking of them as data compressors.
Compressors, like zipping a file. How does that work?
It draws on ideas from information theory. Fundamentally, LLMs are incredibly good at finding patterns, redundancies, and the underlying structure in vast amounts of text data.
So they're not just memorizing.
No, not just memorizing. They're learning the statistical relationships between words, the grammar, the context, the semantic meaning. In doing so, they create a highly compressed, abstract representation of that knowledge.
Like an efficient summary of language.
Kind of, yeah. An information theoretic data compressor. They perform this sort of semantic encoding. When you ask it a question, it uses this compressed understanding to generate a plausible, coherent continuation, a response, rather than just retrieving a stored answer. It's decompressing that learned structure into new text.
That's a really different perspective, compressing knowledge into patterns.
It highlights their ability to generalize and produce novel text based on learned statistical structures.
Fascinating. Okay, let's talk about something relatively new. Machine unlearning, forgetting. Why would AI need to forget?
It sounds counterintuitive, right? We usually focus on learning more, but unlearning is becoming crucial. It's about intentionally removing or weakening specific knowledge the AI has already acquired.
Why?
Several reasons. Maybe the AI was trained on data that included private information that needs to be removed. Or perhaps it learned biased information that needs correcting. Or maybe the information is simply outdated and no longer relevant.
So it helps keep the AI accurate and ethical.
Exactly. It's also important for adaptability. Sometimes, when an AI learns new things, it can suffer from catastrophic forgetting, where the new knowledge overwrites or disrupts older, still valuable knowledge. Unlearning techniques can help manage that.
How do you make an AI forget, though?
There are different strategies being researched. Some involve forms of regularization during training. Others use dynamic memory systems or specialized network architectures. It's related to incremental learning, updating models without full retraining.
And where would this be applied?
Lots of places. Copyright compliance, unlearning protected material if it was accidentally included in training. Personalized recommendations for getting things you're no longer interested in.
Healthcare.
Definitely. Adapting to new medical guidelines by unlearning outdated practices. Autonomous vehicles needing to forget old map data or sensor readings from a construction zone that's now gone.
Bias mitigation seems like a big one, too.
Huge. Unlearning harmful biases learned from flawed data. But it's complex. You need transparency in how it's done. And there are risks of unintended consequences for getting too much, or even amplifying bias in weird ways if not done carefully.
It adds another layer of complexity to managing AI.
It really does.
Okay, moving to the broader picture now. We've touched on biases, but what are some of the other potential downsides or the dark side of AI?
Right. Bias and discrimination are major concerns. Like we said, AI learns from data, and if that data reflects societal biases, gender, race, age, the AI can learn and even amplify those biases.
Leading to unfair outcomes in things like hiring, loan applications, even facial recognition.
Absolutely. Then there's the issue of transparency and accountability. These complex models can be black boxes. We don't always know exactly why they made a particular decision. Who's responsible if it goes wrong?
Good question.
Privacy is another big one. AI systems often require vast amounts of data, sometimes sensitive personal data. How is it collected, stored, used?
Data exploitation is a real risk.
And the more futuristic concerns. Well, there's the development of autonomous weapons AI systems capable of making life or death decisions without human intervention. That raises profound ethical questions. And some worry about existential risks, the long-term possibility of superintelligence posing a threat.
And closer to home, societal disruption, job displacement.
Yes. While AI creates new jobs, it also automates existing ones, leading to significant shifts in the labor market and potential increases in inequality if we don't manage the transition carefully.
Lots to consider there. Now, what about AI hallucinations? You mentioned this with generative AI, but it's broader, right? When AI makes stuff up.
Exactly. It's when an AI generates information that seems plausible but is actually incorrect, irrelevant, or entirely fabricated. It's not limited to just text. It can happen with image generation, too.
Sounds bad. Are there any opportunities in hallucinations?
Surprisingly, yes, in controlled ways. Imagine using AI hallucinations in medical training to simulate rare conditions or unexpected complications for doctors to practice on.
Interesting. Like a flight simulator for medicine.
Kind of. Or in education, generating creative, engaging scenarios. In gaming, advertising, scientific research, sometimes these hallucinated outputs can spark novel ideas or help explore possibilities.
But the concerns must be significant.
Oh, absolutely. The biggest is misinformation. AI generating convincing but false news articles or deepfakes, fake videos or audio used for malicious purposes.
That's scary.
It is. There's also the bias issue. Again, hallucinations might reflect biases in the training data. Lack of transparency, why did it hallucinate that? Privacy concerns if it's hallucinating based on patterns learned from private data. And legal issues around copyright and ownership if an AI hallucinates something new.
So, a powerful but potentially dangerous capability.
Needs careful handling and verification, definitely.
This all seems to lead towards the concept of AI alignment. What's that about?
AI alignment is fundamentally about ensuring that AI systems, especially highly intelligent ones, act in accordance with human values and intentions, making sure they do what we want them to do and don't cause unintended harm.
The alignment problem, right? How do you make sure AI understands and follows our goals?
Exactly. It's a huge challenge. For one thing, human values are complex, diverse, sometimes contradictory, and they change over time. How do you even define them clearly enough for an AI?
Good point.
Then there's the issue of value drift. The AI's goals might subtly change as it learns. Scalability is another problem. How do you ensure alignment in systems that become vastly more intelligent than us? And the risk of adversarial manipulation, someone intentionally trying to misalign an AI.
So how are people trying to tackle this? What are the approaches?
There are several lines of research. Value learning tries to get AI to learn human values by observing our behavior or preferences. Inverse reinforcement learning tries to infer the underlying goals behind our actions.
Learning by watching us.
In a sophisticated way, yes. There's also cooperative inverse reinforcement learning, where humans and AI actively collaborate to clarify the human's goals. And formal verification methods try to mathematically prove that an AI will stay within certain safety boundaries.
It sounds like one of the most critical areas of AI research for the long term.
Many believe it is, yes, especially as AI gets more powerful.
Let's shift to something more tangible. The cost. Why is developing advanced AI getting so incredibly expensive?
Several factors pile up. First, the sheer computing power needed. Training models like GPT-3 or large image models requires massive clusters of specialized hardware GPUs, TPUs.
Which costs a fortune to buy and run.
Exactly. And consumes enormous amounts of electricity. The energy costs alone are significant. Deploying and running these models isn't cheap either.
And the data.
AI has an insatiable appetite for data, high-quality, well-labeled data. Acquiring that data, cleaning it, annotating it, that often requires huge amounts of human labor, which is expensive.
Data labeling farms and such.
Right. Then there's the talent. There's a fierce competition for skilled AI researchers, engineers, data scientists.
High demand, high salaries.
Extremely high. Attracting and retaining top AI talent is a major expense for companies.
And the development process itself.
It's complex. You need multidisciplinary teams. It's often highly iterative, lots of experimentation, training, testing, retraining. That takes time and resources. Plus, building in ethical considerations, safety testing, regulatory compliance that adds to the cost and complexity, too.
So it's a combination of hardware, data, talent, and complexity.
Pretty much sums it up. It's concentrating power in the hands of those who can afford these massive investments.
Let's look at a different kind of interaction. AI and operating systems. How do they influence each other?
It's a really symbiotic relationship, actually. AI is pushing OS design in new directions.
How so?
Well, AI workloads demand better resource management, efficiently handling massive computations on CPUs, GPUs, TPUs. They often require real-time processing capabilities. Security is paramount. And there's a growing need to optimize operating systems for edge computing.
Running AI directly on devices, not just in the cloud.
Exactly, like on your phone, in your car, on factory equipment. The OS needs to be lean and efficient for that.
And how does the OS shape AI?
The OS provides that crucial abstraction layer over the hardware, making it easier to run AI code on different chips. It supports the middleware and frameworks developers rely on, like TensorFlow, PyTorch.
Makes development easier.
Much easier. And modern OS design focuses on scalability for distributed computing running AI training across many machines. Energy efficiency in the OS is also vital, especially for mobile and embedded AI.
Are there challenges at this intersection?
Definitely. Managing the complexity and interdependence is hard. Ensuring security when AI has deep access to system resources, lack of standardization across different hardware and AI frameworks, and everything is evolving so quickly.
Constant change seems to be the theme here.
It really is.
Which brings us back to regulation. How do we make AI responsible? What principles should guide us?
It's a critical discussion. We need robust frameworks. Several key principles emerge. First and foremost, human oversight and control. Humans need to remain in the loop, especially for critical decisions.
Makes sense. Keep humans in charge.
Then, robust security measures. Protecting AI systems from tampering, misuse, or adversarial attacks is essential. Impact assessment is also vital, understanding the potential consequences before deploying an AI system widely.
Thinking ahead about risks.
Right. Collaboration is key, too, involving experts from diverse fields like ethics, law, social sciences, not just tech. Continuous monitoring after deployment is crucial to catch unexpected issues.
And legal compliance.
Absolutely. Ensuring AI adheres to existing laws and developing new regulations where needed. And finally, public engagement, keeping the public informed and involved in shaping how AI is governed.
It's a multifaceted approach to ensure responsible development.
It has to be.
Let's look at some specific applications now. AI and drones, that sounds like a powerful combination.
It really is. We're seeing this convergence of AI enabling much smarter, more autonomous drones or UAVs.
What are the benefits?
AI allows drones to process the huge amounts of sensor data they collect, video, infrared, LiDAR in real time. They can make intelligent decisions on their own, navigate complex environments without constant human piloting, identify objects or anomalies.
So more autonomy, better data analysis.
Exactly. requires tight hardware-software integration for that real-time processing on board the drone itself sometimes.
What kind of applications are we seeing?
So many. Agriculture is a big one, precision farming. Drones using AI to monitor crop health plant by plant, detect pests or diseases, optimize watering and fertilization.
Improving yields, reducing waste?
Right. Surveillance and security, obviously monitoring large areas, border patrol, inspecting infrastructure like pipelines or bridges, logistics and delivery optimizing routes, automated package delivery.
The drone delivery future.
It's starting to happen. Disaster management is another key area, quickly mapping affected zones after earthquakes or floods, searching for survivors using thermal imaging and AI analysis. Environmental monitoring, too, tracking wildlife, monitoring deforestation or pollution.
Sounds incredibly useful. But challenges.
Of course. Privacy concerns are huge with autonomous surveillance. Regulatory hurdles are complex, managing airspace, ensuring safety, and ethical questions about autonomous decision-making, especially in security contexts.
Right. Now, something that sounds even more high stakes. Nuclear AI. AI in the nuclear industry.
Yes, it's the application of AI techniques to nuclear technology, from power plants to research to waste management.
What are the potential upsides? Seems risky.
The potential benefits are significant, focused mainly on safety and efficiency. AI can analyze sensor data from reactors far faster and potentially more accurately than humans, predicting potential failures or anomalies much earlier.
Enhancing safety.
That's a major goal. Also, improving operational efficiency, optimizing fuel usage, maintenance schedules. AI can help design better strategies for managing nuclear waste. And it's being used to accelerate research, particularly in nuclear fusion, by analyzing massive data sets from experiments.
Helping find clean energy solutions.
That's the hope, and it can assist with regulatory compliance, automating data analysis and reporting.
But the risks must be enormous.
Absolutely paramount. Data security is critical, protecting sensitive nuclear information from breaches or manipulation. Dealing with the inherent uncertainty in AI predictions is a challenge you need robust verification and human oversight.
Can't just trust the black box.
Not in this domain. Human-AI interaction needs to be flawless, ensuring operators understand the AI's recommendations and limitations. And the ethical considerations around accountability and transparency are magnified. Plus, navigating the extremely strict regulatory environment for nuclear technology.
Extreme caution needed there.
Understatement of the year.
Let's broaden out again. AI's impact on the environment and climate change. You called it a double-edged sword earlier.
It really is. There's huge positive potential, what you might call a green AI revolution.
How can AI help the environment?
Through optimization. AI can optimize energy grids for maximum efficiency, reducing waste. It can optimize water usage in agriculture or industry, smart building management systems, optimizing logistics to reduce fuel consumption.
So making existing systems much more efficient.
Yes, and fostering sustainable innovation. AI can accelerate the discovery of new materials for solar cells or batteries, help design more efficient renewable energy systems, optimize carbon capture technologies.
And monitoring.
Big time. Enhanced environmental monitoring and modeling, AI analyzing satellite data to track deforestation, ice melt, pollution plumes, improving climate models for more accurate predictions, monitoring biodiversity.
Okay, that sounds great. What's the dark side, the other edge of the sword?
AI's own environmental footprint. Training these massive AI models, especially deep learning models, consumes vast amounts of energy, primarily in data centers.
Contributing to carbon emissions.
Significantly in some cases. And the rapid hardware development cycle for AI chips contributes to the growing problem of electronic waste. There's also the risk of unforeseen consequences if AI optimization leads to rebound effects, like making driving cheaper leads to more driving.
So how do we ensure AI is a net positive for the planet?
We need a conscious effort towards green AI development, designing more energy-efficient algorithms and hardware, optimizing data usage, using AI specifically for environmental solutions, and strong ethical governance to guide its application.
Making AI part of the solution, not adding to the problem.
That has to be the goal.
Which leads to a fundamental question. Who actually benefits most from all this AI?
Well, clearly the pioneers and early adopters, the big tech companies, venture capitalists, industries that leverage AI for disruption, they're seeing huge benefits.
But is it only the giants?
Increasingly, no. Small and medium-sized businesses, SMEs, are also starting to benefit significantly. Cloud platforms and open-source tools are making powerful AI more accessible. It's leveling the playing field somewhat.
What about specific sectors?
Healthcare is a massive beneficiary. AI improving diagnostics, drug discovery, personalized medicine, potentially saving lives and improving quality of life. Education, two personalized learning platforms adapting to individual student needs.
But what about jobs? Automation.
That's the complex part. Automation is happening, displacing some jobs, particularly routine ones. But AI also creates new jobs: AI developers, data scientists, AI trainers, ethicists. The key is job transformation and the need for reskilling and upskilling the workforce.
Is there a risk of it widening inequality?
Yes, that's a serious concern. If the economic gains from AI aren't shared broadly, it could exacerbate income inequality. Ensuring fairness, addressing bias in AI systems that affect opportunities, and managing the environmental impact, these are all crucial parts of figuring out who truly benefits and how we make it benefit society as a whole.
So can we actually stop robots or AI from replacing humans entirely in the workforce?
It's a common fear, but I think there are strong reasons why humans will remain essential. AI is great at specific, often repetitive tasks, but humans excel at things requiring, well, human qualities.
Like what?
Complex, non-routine problem solving that needs creativity, critical thinking, adaptability, emotional intelligence, and empathy vital in roles like healthcare, teaching, therapy, customer service, where human connection matters.
Things machines struggle with.
Exactly. Flexibility and versatility, humans can learn new roles and adapt to changing circumstances much more easily than narrowly trained AI. Contextual understanding, intuition, ethical judgment, these are hard to replicate, and fundamentally, people often prefer interacting with other people, building trust.
So it's more about augmentation than replacement. Humans and AI working together.
Ideally, yes, complementary strengths. But individuals still need strategies to navigate this. Embracing lifelong learning is key, constantly upskilling, especially in areas related to or enhanced by AI.
Learning to work with AI.
Precisely. And focusing on those high-touch occupations, the roles that rely heavily on human interaction, empathy, and creativity will likely offer more security.
Okay, but what about the fear of AI going rogue? Is there a kill switch?
The idea of a kill switch is appealing, a simple way to shut down a misbehaving AI, and it's something researchers consider.
But would it work against a superintelligence?
That's the debate. A sufficiently advanced AI might anticipate and disable such a switch. So, while it's part of the safety toolkit, relying solely on it is probably naive.
So what else is needed?
A layered approach. Robust governance frameworks from the start. Designing AI with inherent safety features and ethical constraints, the alignment problem we discussed. Strong cybersecurity to prevent hijacking. Redundancy in control systems. Crucially, meaningful human oversight. And international cooperation on safety standards.
No single silver bullet.
Unlikely. More like a comprehensive safety culture.
Let's talk about making AI more human-like in its understanding. Multimodal AI. What's that?
Right. Most AI today is unimodal. It processes one type of data, like text or images or sound. Multimodal AI aims to integrate and understand information from multiple sources simultaneously.
Like humans do. We see, hear, read.
Exactly. We combine sight, sound, language, sometimes touch, to get a complete picture. Multimodal AI tries to mimic that. It's essential because the real world is messy and complex. Understanding context often requires fusing different data streams.
Can you give an example?
Sure. Understanding sarcasm in text might be hard, but if the AI also analyzes the speaker's tone of voice, audio and facial expression, video, it gets much easier. It provides disambiguation and robustness. If one data source is noisy or unclear, others can help fill in the gaps.
What's the toolkit for this?
Yeah.
And where is it being used?
It involves techniques for fusing data representations, attention mechanisms that let the AI weigh different modalities. Applications are booming. Healthcare combining medical images, x-rays, MRIs with clinical notes, text, and patient history for better diagnoses.
Oh.
Huge. Robots that can see their environment, hear commands, feel objects they interact with, much more capable and interactive. Customer service chatbots that understand text, voice tone, maybe even video feeds for richer interactions. Media and entertainment analyzing video content by understanding images, audio, and subtitles together.
So a much richer understanding of the world.
That's the goal, closer to how we perceive reality.
But as AI gets more complex, understanding why it makes a decision becomes harder. That brings us to explainable AI, or XAI. Why is this so important?
It's crucial for trust and adoption. If AI systems are making important decisions, loan applications, medical diagnoses, hiring recommendations, but we can't understand their reasoning, It erodes trust.
The black box problem.
Exactly. It makes it hard to detect or correct biases, to ensure fairness, to hold systems accountable if something goes wrong. Sometimes it even reduces effectiveness if users don't trust or understand the AI's output.
So what does explainable actually mean? Does it mean the same thing to everyone?
Not really. It depends on the stakeholder. An end user might just need a simple, clear reason for a decision. Your loan was denied because your debt-to-income ratio is too high. A domain expert, like a doctor using an AI diagnostic tool, might need more detailed insights into which features in an image led to the AI's conclusion.
And for developers?
Developers or auditors need deep technical explanations to debug the model, verify its logic, and ensure it meets regulatory requirements. So explainability isn't one size fits all.
How do we achieve it? What are the techniques?
There's a growing toolkit. Techniques like LIME and SAP provide local explanations explaining why the model made a specific prediction for one particular instance. Others aim for global explanations, understanding the model's overall behavior.
Visualizing the decision process.
Yes, visualizations are key. Counterfactual explanations explore what-if scenarios. What would need to change for the decision to be different? It's about shedding light on that black box.
Are there challenges to making AI explainable?
Definitely. The most powerful AI models, especially deep learning networks, are inherently complex, making them hard to fully interpret. There's often a trade-off. Sometimes making a model more explainable might slightly reduce its predictive accuracy. And the field is still working on standardizing what constitutes a good explanation.
Still an active area of research.
Very much so, and incredibly important.
Okay, let's push the boundaries now. Imagine a hypothetical future AI, a sensate AI, machines with senses like ours, sight, sound, taste, touch, speech.
It's a fascinating thought experiment building on multimodal AI. Imagine an AI that doesn't just process data streams, but has analogs to our senses.
So what would its perception look like?
Its visual cortex wouldn't just see pixels. Advanced cameras and processing could interpret scenes, understand object relationships, infer context. Its auditory cortex would go beyond speech recognition to understand nuances like emotion and tone, identify specific sounds in a complex environment.
And touch?
Highly sensitive tactile sensors could give it a sense of touch, allowing delicate manipulation, texture recognition. A gustatory cortex, maybe using chemical sensors, could analyze composition. Imagine an AI chef tasting its creations, or a medical AI analyzing samples. An advanced NLP and speech synthesis would give it sophisticated linguistic capabilities.
What could such an AI do?